You think the speed of light is just another number, another limit that human ingenuity will eventually overcome. After all, we've broken the sound barrier, escaped Earth's gravity, and split the atom. But Stephen Hawking discovered something that will crush every dream you've ever had about exploring the stars. The speed of light isn't just a speed limit. It's an absolute wall built into the fabric of reality itself, and it's specifically designed to keep civilizations like ours trapped forever. This barrier doesn't just make interstellar travel difficult, it makes it fundamentally impossible in ways that no technology, no matter how advanced, can ever overcome. Hawking realized that the speed of light is the universe's ultimate prison guard, enforcing a cosmic quarantine that ensures every intelligent species remains isolated in their home solar system for eternity. What if I told you that every time you accelerate, you're pushing against the very structure of space and time itself? That the faster you try to go, the more the universe fights back, until reaching light speed becomes literally impossible? Hawking's analysis reveals that the speed of light barrier isn't a challenge waiting to be conquered. It's a mathematical impossibility that gets stronger the harder you try to break it. Before we dive into the mathematical prison that makes the speed of light an unbreakable cosmic wall, hit that subscribe button because we're about to explore the most devastating limitation in all of physics. Stephen Hawking's understanding of the light speed barrier began with Einstein's special relativity, but his insights went far deeper than most physicists realized. The speed of light isn't just the speed at which photons travel, it's the speed at which causality itself propagates through the universe. It's the rate at which cause and effect can spread through space-time, making it the fundamental speed limit of reality itself. When Hawking analyzed what happens as objects approach light speed, he discovered something terrifying. Mass doesn't just increase, it approaches infinity. This isn't a gradual process that you can engineer around. It's an exponential explosion that makes further acceleration literally impossible. As you get closer to light speed, your mass grows so rapidly that all the energy in the universe wouldn't be enough to push you even slightly faster. Imagine trying to accelerate a spacecraft to 99% of light speed. The energy required would be equivalent to the output of our sun for millions of years. But here's where it gets truly nightmarish. To reach 99.9% of light speed would require exponentially more energy, perhaps the output of a billion suns. And to reach 99.99%, the energy of an entire galaxy wouldn't suffice. But mass increase is just the beginning of the nightmare. Time dilation becomes so extreme near light speed that the universe ages around you at an incredible rate. What seems like a few years of travel time to you could represent millions of years passing in the outside universe. You're not just traveling through space. You're traveling through time, watching entire civilizations rise and fall during what feels like a short journey. Think about what this means for any attempt at interstellar exploration. A round trip to Proxima Centauri at 90% light speed would take about 10 years from your perspective. But when you return to Earth, you'd find that nearly 20 years had passed. Everyone you knew would be older, some might be dead, and the world would have changed dramatically. Now imagine pushing closer to light speed. At 99% light speed, that same journey would take about 5 years from your perspective, but over 50 years would pass on Earth. At 99.9% light speed, you'd experience about 2 years of travel time, but centuries would pass in the outside world. The closer you get to light speed, the more extreme this temporal exile becomes. Hawking calculated that this time dilation effect makes the speed of light barrier even more insurmountable than the energy requirements suggest. It's not just that you can't reach light speed, it's that getting close to light speed transforms you into a time traveler, exiling you from your own era forever. The universe uses time itself as a weapon against interstellar travel. The physicist's analysis revealed what he called the asymptotic curve of impossibility. The energy needed doesn't just increase, it follows a mathematical curve that approaches infinity as you approach light speed. This creates a wall that gets infinitely high as you approach it. No matter how much energy you have, you can never have enough to reach light speed because the energy requirement becomes infinite at that point. This is fundamentally different from other barriers humans have overcome. Breaking the sound barrier required more powerful engines. Escaping Earth's gravity required more fuel. But approaching light speed requires infinite energy, a mathematical impossibility that no amount of technological advancement can solve. But Hawking discovered something even more disturbing about the light speed barrier. It's not just about individual particles or spacecraft. The barrier applies to information itself. No information can travel faster than light, which means that even if you could somehow exceed light speed, you couldn't communicate with anyone about it. The universe doesn't just prevent faster-than-light travel, it prevents faster-than-light communication, ensuring that the barrier remains absolute. Consider the implications. Even if aliens develop technology that seemed to exceed light speed, they couldn't send us a message about it faster than light could carry that message. The universe maintains its speed limit by making it impossible to prove that the limit has been broken. It's the perfect cosmic enforcement mechanism. The physicist also realized that the speed of light barrier is intimately connected to the structure of space-time itself. Space and time aren't separate things that objects move through. They're aspects of a single four-dimensional fabric that has light speed built into its fundamental geometry. Trying to exceed light speed isn't like trying to go faster than sound through air. It's like trying to move faster than the medium of existence itself. This geometric understanding reveals why the light speed barrier is truly unbreakable. You're not trying to overcome a force or push through a medium. You're trying to violate the basic structure of reality. It's like trying to draw a square circle or create a married bachelor. It's not just difficult, it's logically impossible within the framework of our universe. Hawking's analysis also showed why exotic propulsion concepts like warp drives can't overcome the light speed barrier. The Alcubierre warp drive theoretically allows faster-than-light travel by contracting space in front of a spacecraft and expanding it behind. Sounds promising, right? Wrong. The energy requirements for creating such space-time distortions aren't just enormous, they're infinite. The physicist calculated that maintaining a warp bubble would require exotic matter with negative energy density, and the amount needed would exceed the mass energy of the observable universe. You'd need to convert more matter than exists in all the galaxies we can see just to power a single warp drive. Even if such exotic matter could exist, creating and controlling it would require technologies that violate the same physical laws that make faster-than-light travel impossible in the first place. It's a cosmic catch-22. To break the light speed barrier, you need technology that can only exist if the light speed barrier is already broken. Wormholes face similar problems. Even if they could be created, they would collapse the moment anything tried to pass through them, unless held open by exotic matter that probably can't exist. The energy requirements for keeping a traversable wormhole open are so enormous that they make the wormhole itself pointless. You'd need more energy than exists in the universe to create a shortcut through the universe. But perhaps most devastating was Hawking's realization about the relationship between the speed of light and causality. Faster-than-light travel isn't just prohibited by energy requirements, it's prohibited by logic itself. If you could travel faster than light, you could arrive at your destination before you left, creating paradoxes that would violate the fundamental principle of cause and effect. Here's a simple example. Imagine you could travel to Alpha Centauri faster than light and send a message back to Earth. Due to the relativity of simultaneity, that message could arrive before you originally left. You could literally send yourself a message telling yourself not to make the trip. This creates a logical paradox that threatens the consistency of reality itself. The universe seems designed to prevent such paradoxes. Every time physicists discover a potential loophole that might allow faster-than-light travel, they find that the same physics that creates the loophole also makes it impossible to exploit. It's as if reality has built-in safeguards against its own violation. Let me ask you something that might change how you think about the nature of reality itself. If the speed of light barrier is truly unbreakable, and if it's built into the fundamental structure of space-time, what does that say about our place in the universe? Are we prisoners of physics, or is this barrier actually protecting us from something worse? Share your thoughts in the comments below, because the answer might reveal the deepest purpose of physical law itself. The physicist understood that the light speed barrier creates what he called causal isolation between distant regions of the universe. Events happening right now in distant galaxies cannot affect us because the information about those events can't reach us faster than light. Similarly, our actions cannot affect distant civilizations because the information about our actions can't reach them faster than light. This isolation has profound implications. Right now, as you're reading this, entire civilizations might be rising and falling in distant galaxies, but their fate cannot influence ours. and ours cannot influence theirs. Each region of the universe is causally disconnected from distant regions, creating a cosmic archipelago of isolated islands of causality. Hawking's analysis revealed that this isolation might be necessary for the stability of the universe itself. If faster-than-light communication were possible, then events in distant regions could create feedback loops and paradoxes that might destabilize the entire cosmic system. The light-speed barrier serves as a cosmic circuit breaker, preventing runaway causality chains that could tear apart the fabric of reality. Consider what would happen if the light-speed barrier didn't exist. Civilizations could communicate instantaneously across the galaxy, creating a vast network of interconnected intelligence. But they could also create paradoxes by sending information into their own past. The universe might become unstable, with cause and effect becoming tangled in impossible knots. The physicist also explored how the light-speed barrier affects the evolution of intelligence in the universe. If civilizations cannot communicate or travel faster than light, then intelligence must develop independently in isolated pockets throughout the cosmos. Each civilization becomes a unique experiment in consciousness, developing its own understanding of reality without influence from other intelligent species. This forced isolation might actually be beneficial for the development of diverse forms of intelligence. If civilizations could easily communicate across interstellar distances, they might all converge on similar solutions to the problems of existence. The light-speed barrier ensures that the universe develops a rich diversity of different approaches to intelligence and consciousness. Recent experiments have only reinforced Hawking's understanding of the light-speed barrier. At CERN's Large Hadron Collider, physicists routinely accelerate particles to 99.9999% of light speed, but they can never quite reach that final barrier. No matter how much energy they pump into particles, the light-speed wall remains absolute. Quantum entanglement experiments have shown that particles can be correlated instantaneously across vast distances, but no usable information can be transmitted through this correlation. The universe allows quantum connections that transcend space and time, but prevents those connections from being used to violate the light-speed barrier. It's as if reality teases us with hints of faster-than-light phenomena while ensuring we can never exploit them. Studies of cosmic rays, particles accelerated by the most violent events in the universe, show that even these natural particle accelerators cannot break the light-speed barrier. Supernovas, black holes, and galactic collisions pump enormous energies into particles, but they all hit the same wall that stops our earthly accelerators. The physicists' work also revealed why even theoretical concepts like tachyons cannot exist in our universe. Tachyons are hypothetical particles that would travel faster than light, but if they existed, they would create paradoxes that violate causality. The universe seems designed to prevent such paradoxes by making faster-than-light particles impossible. Every mathematical model that allows tachyons also predicts that they would be unstable and would decay into slower-than-light particles. It's as if the universe has an immune system that destroys anything that threatens the light-speed barrier. Hawking understood that the light-speed barrier has profound implications for the future of human civilization. We will never explore distant galaxies, never meet alien civilizations from other star systems, and never establish a galactic empire. Our cosmic horizon is limited by the distance that light can travel during the lifetime of our civilization. But the physicist also recognized that this limitation doesn't diminish the importance of human achievement. If we cannot spread across the galaxy, then our development of science, art, and consciousness becomes even more precious. We are one unique experiment in intelligence among countless others scattered throughout the cosmos, each developing in isolation behind the light-speed barrier. The barrier also means that our actions have cosmic significance. If we destroy ourselves or fail to develop our potential, that unique form of consciousness represented by humanity will be lost forever. No other civilization can replace us or learn from our mistakes because they're all isolated behind their own light-speed barriers. This cosmic isolation creates both responsibility and opportunity. We are responsible for developing our own potential because no one else can do it for us. But we also have the opportunity to create something truly unique, a form of consciousness and civilization that has never existed before and will never exist again. Hawking's analysis suggests that the light-speed barrier might be the universe's way of ensuring that consciousness and intelligence remain diverse and resilient. By preventing any one civilization from dominating the galaxy, the barrier ensures that the universe develops multiple independent forms of awareness, each contributing its own unique perspective to the cosmic understanding of existence. The physicist also speculated that advanced civilizations might eventually learn to accept and even appreciate the light-speed barrier. Rather than seeing it as a limitation, they might recognize it as a feature that preserves the diversity and independence of intelligent life throughout the universe. The barrier becomes not a prison, but a protective boundary that allows each civilization to develop its full potential without interference. Think about it this way. If faster-than-light travel were possible, the first civilization to achieve it might spread across the galaxy, homogenizing intelligence and preventing other forms of consciousness from developing. The light-speed barrier ensures that every star system gets its chance to develop unique forms of life and intelligence. Stephen Hawking never lived to see humanity fully accept the reality of our light-speed imprisonment, but his analysis provides a clear understanding of why this barrier cannot be overcome. The speed of light isn't just a speed limit, it's a fundamental feature of reality that ensures the universe remains stable, diverse, and causally consistent. The physicist's legacy extends beyond physics into philosophy and the meaning of existence itself. If we are forever trapped behind this barrier, then our task is not to escape, but to make the most of our cosmic situation. We must develop our consciousness, explore our local region of space, and create meaning within the boundaries that physics has set for us. So the next time you see light traveling from distant stars, remember that you're witnessing the speed of the ultimate cosmic barrier. That light carries information from distant worlds, but it also represents the maximum speed at which any information can travel. The stars you see are not destinations for future human explorers, but distant beacons marking the positions of other civilizations, each as isolated and alone as we are behind their own light-speed barriers. The universe has given us a solar system to explore and develop, but it has also given us an absolute boundary that we can never cross. The speed of light barrier is not just a limitation on travel, it's a fundamental feature of reality that shapes the nature of existence itself. Understanding this barrier is crucial for understanding our place in the cosmos and the true scope of human possibility. We are not prisoners of physics. We are participants in a cosmic experiment in consciousness, one of countless such experiments scattered throughout the universe. Our isolation is not a punishment, but a gift, ensuring that we develop our own unique understanding of existence without interference from other forms of intelligence. If this exploration of Stephen Hawking's analysis of the light-speed barrier has fundamentally changed how you understand the limits of human exploration, make sure to smash that like button to support more deep dives into the physical realities that govern our universe. Subscribe to our channel and hit that notification bell so you never miss our latest investigations into the fundamental barriers that define the boundaries of existence. Share this video with anyone who's ever wondered why we can't travel faster than light, because understanding this limitation is crucial for realistic planning of humanity's future. And let me know in the comments, if the light-speed barrier is truly unbreakable, how should that change our approach to space exploration and our search for meaning in the universe? Does this cosmic isolation make our civilization more precious or more tragic? What should humanity focus on if we can never leave our local region of space? Drop your thoughts below and join our community of cosmic realists as we continue to explore the true boundaries of physical possibility. The light-speed barrier may define our cosmic boundaries, but understanding those boundaries is the first step toward making the most of our unique place in the universe.